Hello, under quadratic applications, here is another problem for you. A group of students chartered a bus for $60. When 4 students withdrew from the group, the share of each of the other student was increased by $2.50. How many students were in the group originally? Right. So when they were all the students, they were sharing $2.50 lesser. Now when 4 withdrew, then their expenses have gone up by $2.50. We need to find originally how many people were there, correct? So let's assume, so let us say, let X students be there originally, okay? Or charter the bus, right? Let X students be originally involved. Correct? Now 4 has withdrawn, and because of that the number has become X minus 4, right? X minus 4. Now if there were X students originally, then how much did they share? A group of students chartered a bus for a total of $60. So if X are there, then their share was 60 over X each, right? This is initial, right? This is original, right? So let me write, this is initial. Right? Now, final is how much? Final is more by $2.50. So initial plus $2.50 is equals to final. And final is how much? Final is 60 divided by X minus 4, because 4 have left. So only 4 less will be sharing the amount, right? So they pay more. Do you understand the equation now? So that is how we can relate our function. So the tricky part in the word problems is to get the right equation. Once you get the right equation, then it's simpler to solve, right? So now of course what we will do is we will see the lowest common denominator. That's the common policy. Get rid of fractions, right? Multiply by common denominator, and then you have a simple statement, a quadratic equation most probably. Solve it. That's the best way to do it, right? So we'll multiply each term here by x times x minus 4, right? So here we will get 60 times x minus 4, right? So let me write this. 60 times x minus 4, and for this we get 2.5 times x, because the denominator is 1 here, times x minus 4, and here we will get 60 times x, correct? So that's your equation. Now we'll solve it. So open the brackets and reorganize. So we'll have 60x minus 240 plus 2.5 x square minus 2.5 times 4 is 10, right? So 10x, because this x will get multiplied, so minus 10x equals to 60x. Now we'll bring the terms together and we'll write this as in the first place. Leading coefficient is 2.5 for us. Then the x terms are 60x, and this 60x comes here, so they get minus, and you get minus 10x. So you're left with just minus 10x, right? So, okay. You want me to write both? Let me write like this. So plus 60x minus 60x minus 10x and minus 240 equals to 0, correct? This is what we are left with, and we'll simplify this, and we have 2.5 x square, and this is left with minus 10x, and here we have minus 240 equals to 0, right? Now from here we can take 2.5 common. Do you see that? So we can say 2.5, and within bracket we get x square here, and if you divide 10 by 2.5, 10 divided by 2.5 is 4, we get 4x, and 240 divided by 2.5 is 96. So we get minus 96 equals to 0. Now, so we need product of 96, which is equals to minus 96, and we need sum, that is p plus q, of minus 4, right? So how to get these numbers? So we'll follow the same method. We can factor 96, right? So we have 96 and we try to get factors. You can say this is 3 times 32, right? And then you can factor 32 and you get 8 times 4. Now we need difference of 4. So difference of 4 is 4 times 3 is 12. Yeah, we got it. So we will club it like this. We'll take 8 separately and we will use 3 and 4. So we got our numbers, which is 12 and 8. And which is going to be bigger? Bigger number is 12. So we can write this as 2.5 times x, and 8 should be negative. 12 should be negative. So minus 12 times x plus 8 equals to 0. Correct? Now, what is the solution? The x could be either 12 or minus 8. So from here, x equals to 12 or x equals to minus 8. Well, that is not valid. 12 is okay. So originally, how many people were there? There were 12 students originally. So answer is 12 students originally. Correct? I hope you understand how we did it and you appreciate our method of doing it. Fine. Thanks.